So let's go ahead and do a little recap on critical numbers. So recall that a critical number for a function f is a value x equals a in the domain of f where either f prime of a is equal to 0 or f prime of a is undefined. So remember that in order for me to identify critical numbers or for me to find critical numbers, I either need to figure out where exactly the derivative is equal to 0 or where the derivative is undefined, which is kind of like something that a lot of students tend to forget. To also check where this guy is going to be undefined. So a critical point for a function f is a point a comma f of a, where a is a critical number of f. Okay, so imagine that here, critical number, we're just looking for the x value. And then critical point here is basically the x and y value. So you do have to do an extra step in order for you to find the critical point, because once you find our x value, we would have to go ahead and plug it in. So again, this is how you find critical points. We want to find the derivative of the function. We want to set the derivative equal to 0 and solve for the critical numbers. So don't forget to check where the derivative is undefined. And also plug in the critical number to find the point. So now this second part is going to be optional. Well, not optional, more like if they specifically ask you for the critical point, then you do have to do step number 3. If they are asking you for the critical number, then you just got to do steps 1 and 2. Okay. Now, and I'm going to make a separate video on critical numbers, but then with asymptotes. So that's going to be a little different. And I think that's where the confusion was in class this past week. So let's go ahead and do some examples. So here we're just going to find the critical number. So we're not going to do number 3. Number 3, that if you're looking for the critical point, then you would plug in the x value back into the original equation, and you'll be able to find the y value. So do keep that in mind, that whenever you want to find the critical point, we're talking about plugging it into the original. So you plug in into original function. Okay, so let's go ahead and do some examples on just finding critical numbers, just so that we can get practice, because I think that's probably the hardest part. So remember, in order for me to find critical numbers, we need to figure out where exactly the derivative is equal to 0 and when it's undefined. So find the critical points. So here we have y equals 2x minus x squared. Let's take the derivative. So we got y prime equals 2 minus 2x, and we're going to set this guy equal to 0. Okay, so one of the things that I like to take a look at is look at the function and see if the function itself is going to be undefined. And actually it isn't, right? Because there's no x values in the denominator. This was a polynomial, so you don't need to check. It's all real numbers, so it's never going to be undefined. So let's go ahead and solve it. So I'm going to move the 2 over. So you get negative 2x equals negative 2. And then I'm going to divide by negative 2. And I get x equals 1. So that's one of my critical numbers. All right. So that's my first one. Cool. All right. Now let's try the next one. So we have y equals 2x cubed plus 3x squared minus 12x plus 5. So let's go ahead and take the derivative. So y prime, this is going to give me 6x squared plus 6x minus 12. And what I'm going to do is I'm going to set this guy equal to 0. So notice I can take out a 6, x squared plus x minus 2. And then let me go ahead and factor this. So I get an x and an x, a 2 and a 1. So this is going to be a plus and a minus. So you can see 6 equals 0. That's not going to really give you anything. You got x plus 2 equals 0. And you got x minus 1 equals 0. So you get that x equals negative 2. And x equals positive 1. Okay. Again, if you were looking for the critical points, you would plug 2 and 1 back into the original to get their y values. Okay. So that's it. That's how you find these two critical numbers. Notice that the derivative itself wasn't undefined, so I didn't have to look at anything. All right, now let's take a look at this next example. So f of x equals x plus e to the negative x. So let's take the derivative now. So it's f of prime of x equals 1 minus e to the negative x, because we need to use a chain rule there. Because the derivative of e is e to the negative x times the derivative of negative x, that's just going to be negative 1. That's where this negative came in. And we're going to set that equal to 0. So we're going to minus the 1. Negative e to the negative x equals negative 1. Now we're going to divide by that negative 1. So I'm going to get e to the negative x equals positive 1. And now we're going to get rid of that e. So what we're going to do is we're going to apply natural log to both sides of that e to the negative x 1. So then this is just going to give me negative x equals ln of 1, which is 0. So basically x equals 0 is my critical number. Okay, you can see that this x equals 0, when I plug it back in, I end up getting, I'm sorry. You can also see that 1 minus e to the negative x, that's what I was going to say. This guy, that derivative itself is not undefined as either. Exponential functions have a domain of all real numbers, so this one doesn't really have to do, you don't really have to look at anything. All right. And now let's take a look at this guy, part D. Okay. So part D seems a little bit more involved. So let's go ahead and take the derivative of this guy. So notice that I have two functions, so I have to use the product rule here. So y prime. So I do have to use the product rule. All right. So in the first parentheses, I'm going to have this x to the 4/5. I'm going to write x to the 4/5 over here. And then in the middle parentheses, I'm going to have x minus 4 squared. And now let's take the derivative of this. Let's go ahead and take the derivative. So it's going to be 4/5 x to the minus 5/5. That's going to give me negative 1/5. And then we're going to have this one by itself, x minus 4 squared. Okay. And then we're going to have the derivative of this guy. So I'm going to move the 2 over. That's going to give me 2x minus 4. And then I'm going to subtract by 1, which is going to give me a positive 1. And then multiply it by the derivative of the inside, which in this case is just 1. And then we have x to the 4/5. Okay, and now we're going to set this guy equal to 0. Okay, so what I'm going to do, well, there's many different things that you can do in this case. One of them you can factor out in the highest powers, but this is what I'm going to do. What I'm going to do is I'm going to move this guy over. So minus 2x minus 4 x to the 4/5 to the other side. Okay. I'm going to move that over, and I'm going to have 4/5 x to the negative 1/5 x minus 4 squared equals negative 2 x minus 4 to the x to the 4/5. All right, so now let's go ahead and move this guy down. So I can write it as 4x minus 4 squared. I have a 5 already on the bottom, and I have an x to the 1/5 on the bottom as well. And this guy, I just have negative 2x minus 4 x to the 4/5 over 1. Okay, what you can do is just can cross multiply. Cross multiply. So I'm going to have 4x minus 4 squared equals, and I'm going to have 5 and negative 2 is going to be negative 10. X to the 1/5 times x to the 4/5, that's going to give me x to the 5/5, x to the 5/5, which is just going to be x, and then we're just going to have an x minus 4. All right, let's go ahead and FOIL everything. So I'm going to have 4x minus 4 times x minus 4 equals negative 10x, x minus 4. So let me go ahead and FOIL this guy. So it's going to be 4. This guy is just going to be x squared minus 8x plus 16. This guy also, this is going to be negative 10x squared plus 40x. All right. So I have 4x squared minus 32x plus, what is it, 64, negative 10x squared plus 40x. So now I'm going to add the 10x squared, and I'm going to minus the 40x. So I get 14x squared, and then you're going to have this negative 40 minus 32. That's going to give me negative 72x. You're going to get this positive 64 equals 0. Okay. All right, and now let's go ahead and see if we can factor that guy. We can take out of 2, so you have 7x squared. And then this one, 72 divided by 2, that's going to give me 36x. And then this last one's going to give me a 32. So at this point, what you can do is you can use polysolver if you want in your calculator, or you can just factor this guy out. Attempt to factor this. I think this is factorable. Let's see. 7 and 1. 8 and 4, I think. I think this works. Yeah, this works. Okay. So then you get 2 equals 0. Well, that's nothing. 7x minus 8 equals 0. And then x minus 4 equals 0. So here you got x equals 8 over 7. And here you got x equals 4. Now you're not done yet, okay, because this is not it. Because all we've just looked at is where the derivative is equal to 0. Now what we got to look at is where the derivative is undefined. So if you take a look at the derivative itself, right, which is this blue part, let me go ahead and get rid of this guy. So if you look at this blue part, is this derivative undefined anywhere? And the answer is yes, it is, okay? And you can even look at it here if you kind of just go in this direction also. You can see that the derivative is undefined in this direction in x to the 1/5. So because x to the 1/5, you can rewrite it as 4 over 5x to the 1/5. And all you really got to do is now take that guy, because this guy's undefined, and set it equal to 0. And you can just see that the only possible answer will be x equals 0. So x equals 0, x equals 8 over 7, and x equals 4 are all critical points. Okay, are all critical numbers in this case. So this one is where the derivative is undefined. And this one's when the derivative is equal to 0. Okay, so you always have to check this one as well. So in the next video, what I'm going to do is I'm going to show you an alternate way to go ahead and solve this one without having to do all of this algebra. So stay tuned for that one.